Hello. All right. Hi, everyone. Very warm welcome to this talk on how elastic is your cloud. So my name is Sowmya. I work with Accelerite as a chief product engineer. I've been working with CloudStack for about 4 years now, and I specialize in performance testing of CloudStack, as well as I work on the NetScaler integrations and a little bit on the storage side. All right, so how elastic is your cloud? So this again started off as I have done a couple of few talks before for the Collab, talking about CloudStack scalability, talking about CloudStack performance, right? There are virtual router related performance tests, and in general, how much you can scale CloudStack to, in terms of production environments. So this talk is a more generic talk on how much of, for example, what happens when you scale up your CloudStack to, let's say, 25,000 VMs, or what happens when you actually deploy 25,000 VMs one after the other in a very short interval of time, right? So this talk focuses on specific use cases of that sort. And hopefully I'll also be able to highlight some of the configs or some of the configurations which are needed for, which actually helps in scaling up your cloud based on your requirements. So what does elasticity mean, really? Elasticity means different things to different people, depending on the kind of cloud that is being operated, right? So there could be, for example, how many virtual machines, like I said, can be deployed in a cloud with end resources? Based on some of the customer escalations and customer requirements and calls that I have come across, the number of resources, when we say resources, it could be the number of hosts that are present in that infrastructure. It could be the capability of the network that is present in the infrastructure. It could be the kind of storage solution that you have. So we will look at some few examples of simulator runs which I have done, which will tell you about what really happens when you scale up your infrastructure to, let's say, 25,000 or 30,000 VMs, right? So given that we cannot exactly afford such a huge infrastructure in the lab, most of these tests are run using simulator. Right, so the other aspect is about how, let's say, quickly can I deploy these VMs. This is very critical in cases like, desktop as a service. Let's say there are a lot of, let's take, for example, Zen Desktop, right? So if you have a company which is having a desktop as a service for their private, as part of their private enterprise, people come in at 9 a.m. and everyone turn on their machines, and there are like maybe 100 machines 100 VMs trying to come up in the first 5 minutes, and another 100 in the next 5 minutes, and so on. So how quickly can I deploy these VMs also matters, right? It's not just about how many of those in the given infrastructure, but also about how quickly these VMs are able to come up. So what happens here when you say how quickly the VMs are able to come up? It means how quickly CloudStack is able to figure out resource for these VMs to sit in, how quickly it's able to do the deployment planning, how quickly it is able to figure out which storage pool should I use, what is the best host with free capacity, whether I should use, let's say it's using first fill planner, what happens when the first 5 hosts are not available, it moves to the second host. So how well we can optimize this, how well this has been optimized. We will look at some of those numbers later. Shifting gears a little bit, coming into the networking side. Let's say you have a 1 gig virtual router in your network, and what happens when you deploy 10,000 LB rules? Let's say the virtual router is handling LB using HA proxy. What happens when you deploy 10,000 LB rules? What happens to the traffic? How much of RPS can you get, right? So I don't have exactly that particular use case, but we will definitely see how much you can scale up with a 1 gig router, 64-bit, and I think we'll look at some of the configurations of virtual router and how much of RPS we can get given this kind of a configuration. Finally, this is another use case which is extremely critical: list APIs. So list APIs are an integral part of the CloudStack UI. Any single resource or any single tab or any most of the APIs or the tabs in the dashboard, for example, everything is going to trigger a list API. So when you have, let's say, 35,000 virtual machines in your infrastructure and you do a list virtual machines, obviously you do not want that to be impacted, right? The UI is the first, any end user at any point in time, the UI is going to be impacted. It's going to be accessed. So we have had some major, we have had some issues with list APIs which we have resolved in the past. And, this is one of those first interfaces which a user comes into, and we obviously want the best possible experience out there. And this is one of the critical bits of APIs which has to be tested release over release, to ensure that there are no issues, because this can have a long-reaching impact on the UI. So let's deep dive into each of these use cases. And see where it goes. So there could be a lot of more use cases, and this is not, of course, an exhaustive list, but these are the foundational aspects, or the foundational aspects which any cloud admin would be worried about, when he's planning to scale up. All right. So here is one of the, so to address the first part of that virtual machine deployment, how many, right? How many can I deploy? Like I said, this is a simulated infrastructure. I had around 4,000 simulated hosts set up in this infrastructure. And I tried to deploy as many VMs as possible. I had around 4,000 accounts, and this was an RVR setup. So I have around 8,000 routers running there. So one thing which we would see is this particular deployment had I think 24 roughly around 30k VMs, out of which 15k are expunged. Now that also contributes, right? The deleted VMs in an infrastructure are not dead resources. They ultimately are sitting in the DB, and whenever we are doing any kind of DB call to the VM instance table, it might get impacted, right? So obviously we need the indexes to be set up properly. So the indexes have to be set up right, and so on. So this particular setup, which had around 4,000 hosts and which had around 4,000 accounts, could scale up easily up to 35,000 VMs. So how long did it take for me to deploy these VMs? We'll take a look at that. Right. So how long did it take? The first 12k VMs is what I kind of graphed out here. So what you see here is the time taken for the async job to get completed. When you fire a deploy VM async job, how long did it take for it to complete? Obviously, this will not include the time for the applications in the VM to come up. We are looking at how long does CloudStack take to figure out a host and a storage pool for the VM to be deployed in, right? So what you see there is that around 6,000 or so, right? When around 6,000 or so VMs take about roughly 5 seconds, to come up, right? To come up in the running state, which is pretty good. The spikes that you see very often are because there are every new network is going to launch 2 routers. This is an RVR setup. So the spikes are because the couple of virtual routers take longer to deploy.
What's the rough specs for your repeat?
What are the?
Rough specs.
Oh yeah, I'll get to that. So I use a management server, which is for this I think I used 16 gig, and I'll come to the specs, right, of management server and the DB server, right? Just it's a couple of slides ahead. So the first set of 6,000 VMs are pretty okay, and you see that the average deploy time takes longer and longer. Why is that? So when when a VM is getting deployed, and let's say the first host it hits is going to be free, then obviously it's going to deploy on that particular host. Now, as it reaches more and more VMs and more hosts are being consumed, and the capacity is to be calculated in each of these hosts, it finds that more and more hosts are getting filled up, right? So probably the 7,000 VM is going to take longer to figure out a free host, because there are a lot of hosts which are filled up, and it has to do a lot more search to figure out where can I get a suitable host. Same with the storage pool. So that is the reason why you see that beyond 6K VMs, the average time taken for the VM deployment increases, right? But even in that case, I think roughly an averaged out 35-second is kind of pretty good in terms of the infrastructure of this scale. Right. So the next part of virtual machine deployment is, which is equally important, is the time taken for that particular deploy VM API itself to return, right? Or as soon as you fire an API, what response you get? How long does it take to get? How long does it take for you to get a response? That is also very critical. So that is what it's essentially the time taken to return the job ID once you fire a call, right? So that has to be, for most APIs, we target it to be around 0 to 5 seconds, which is what is the case here. The 11,000 set of VMs took a slightly longer time, but you see that more or less most of the VMs are taking between 0 to 5 seconds on an average to return the job ID. So here are the specs for the management server. So for this kind of a test setup, obviously, cloud providers use much better servers. But when I'm running my tests, I do not want to set the bar too high, right? We obviously want to test on something as minimalistic as possible. So I have taken a 16 CPU 2 gigahertz box, and this was a clustered management server setup with 2 management servers clustered, running redundantly. The Java heap size was set to 8 gig, and you need to set the DB active connections to at least 500 if you're scaling up to this many VMs. The DB server slightly has a better capacity from what I figured. It was a 32 gig server, and you typically set the buffer pool size to 80% of your RAM. And another thing which had to be optimized in the DB server was that MySQL was running off a separate SSD hard disk, right? So I mount the MySQL into a separate hard disk, and that's again, it actually enhances your performance of the DB. So it was also a 16 CPU box, and this kind of minimalistic server configuration actually was good enough to scale up to as much as 35,000 VMs in a 4,000 host simulated setup. And I thought that was pretty okay. Right, so that is one aspect of the scalability. How much, in other words, how elastic your cloud is. So this is one such parameter in terms of compute. So switching gears a little bit, like I spoke before on the networking side, this was another test which I run specifically on the virtual router. This was a comparison between Hyper-V and Zen server, which was slightly different, but that's okay. It was not too much impacting. So what I did was I created a load balancing workload with virtual router, and I had around, I just use a Apache bench to fire 100 concurrent connections with around 100,000 requests. So what happens? I mean, what is the RPS that you get with this? So I targeted for a VR which was 2 gigahertz and 2 core CPU and 1 gig RAM. And this was the amount of RPS that I got. It was roughly, for Zen server, I could get close to 2,000 RPS. And I assume these are good measures from, when I have tried to simulate production server installations, I found that this was pretty good in terms of how our VR performed in this part. So one thing which I could not exactly figure out was why was Hyper-V versus N-Server varying so much. Now some more tests need to be done there to figure out, was that particular time when I hit the network, was it peak, or was it exactly standardized and so on. But still, this was a pretty good indication of how much. Obviously you cannot do this with a smaller router. You need at least 1 gig router to get this going, and you also need some CCTL configurations to get this going. I'll attach an addendum later to give you those configurations. Right, finally the list APIs. So like I mentioned before, list APIs is critical for any of the UI, user experience in the UI, and every single resource or every single tab is going to do a list API call. So as your resources increase, you do not want your list APIs taking longer. So presently the way it works is it does a list API call, but when a list API call is done, you get the number of objects in the response, right? And that objects is what is used by the UI to retrieve the number which you see, for example, in your dashboard as soon as you log into CloudStack. So these are some response time which I got in that same setup, which had 35,000 VMs running. So list virtual machines. I'm sorry, you probably cannot read those, but I'll read it for you. So the first one is list volumes with storage ID, and the second one is list virtual machines with host ID. So a typical list API, not necessarily is just going to be a list call. It's probably going to be attached with some parameters. You want to list all the virtual machines in a host, for example, right? So that's what you see there. So the y-axis is the time taken in seconds, and the x-axis is the API which I fired. So the second bar that you see there is list virtual machines with host ID. So I'm giving the host ID and it's listing the virtual machines in that particular host, which barely took 1 second. And I thought that was the best possible user experience that you can get, right? And the second one was list virtual machines with network ID, and so on, with storage ID, account ID, and so on. What you see, the last but 3 is list hosts with cluster ID, right? And the last one is list networks with an account ID. So list networks call, yes, please. Oh, so every virtual machine, so the question was how many volumes did the virtual machines have? So every virtual machine had a single root disk. So I had around 35,000 volumes as well. Yes, so the earlier number that I showed you here, so for these many, all of these graphs are being done for this setup, which had this many VMs running. Right, so we had around 25,000 active VMs and 15K deleted VMs. Right, so so like I said, I mean the list API calls are so this is something which I try to do release over release. These are tests which I try to do every release to ensure that we don't break something very seriously bad, especially in terms of list API or deploy VM numbers. So that's pretty much what I had. Any other questions? Sorry?
Are the tools that you use to run those tests available for general use, so we can add it into our testing frameworks?
Sure. So this is just the simulator setup. I just have a set of scripts which I use for setting up the zone and setting up the RER network offering, and that's it. Rest of it is it's just a list virtual machine or deploy virtual machine call, which is probably running like 25,000 in a loop, right, for every account. So it's just a set of shell scripts which I can probably upload it to GitHub, to my GitHub. Yeah.
More questions? No? All right. Thank you very
guys.
much.
Thank you.